Right, last lesson we started looking at type 1 and type 2 errors. Can somebody who was here last time remind us, first of all, what is a type 1? And we always seem to use these Roman numerals for these. What is a type 1 error? Rob?
When you accept H1.
Yeah, it's the probability you accept H1 given that H1 is actually false. It's when you accept H1 when you shouldn't. So can somebody else tell us what a type 2 error is?
You reject H1.
You reject H1, yes, in other words you accept H0 when...
H1 is true?
Yes, or H1 naught is false, yeah. What you said is right. We normally try and say what you accept here before the line. So when you said rejecting H0, that's exactly the same thing. But we normally think of it as what we accept here, and that thing that we accept is actually being false over there. We were part way through an example. I think at the end of the example we had an Alex principle.
Yeah.
Yes, we did.
We had an Alex principle, okay, to compete with the Billy principle. We had worked out that for the question, quick recap on the question, jam jars, sample 25, found a critical value for 5% and found out the probability of different errors. We found that if we were using a significance level of 5%, the probability of a type 1 error was 5%, because for a significance test, for continuous data, a type 1 error probability and a significance level are the same thing. That was, okay, and that was big. If we made this one smaller, if we lowered this from 5% to 1% to make this error here smaller, we raised this error over here. So we said it was true that if you try to reduce the type 1 error, then the type 2 error increases. And Alex then said, Q Alex.
You've got to have a decent sized sample, otherwise it's worse.
Yes, okay. Basically, to reduce both of them, you need to increase the sample size. So we're just going to get there in a minute. So it says down here, in this question, the consequence of setting the significance level at 5% meant that there's a probability of 5% of unnecessarily stopping the machine filling the jars when it was working correctly. Because that 5%, that's a type 1. That's when you accept H1 when you shouldn't have done, when you think there's a problem when actually there isn't a problem. That led to an 8.7% chance that we would fail to stop the process if there really was something wrong. That was at the 5% level. It became more extreme at the 1% level. 1% level, we would unnecessarily stop the machine working 1% of the time, but there's a 25% chance that we would fail to stop it if something went wrong. And he said, in setting a significance level, it may be necessary to assess the risks involved in a type 1 error and a type 2 error, which is the most important sort of error, which is the one you want to avoid the most. And this is basically the Alex principle here. The only way both types of error can be reduced at the same time is by taking a larger sample. This is what I then have in the notes, and I actually look back and I can't actually find on page 139 to page 143 of your textbook anything particularly relevant, so I'm assuming that must have applied to an old edition of the textbook. So if you see that and you printed that out, I don't think those page numbers now make sense. That was the example we looked at. The main thing to get from that is the Alex principle. As one thing goes up, the other goes down. The only way to make a both smaller is to increase the sample size. We are now going to look at another example, example number 2. If you have got the handout bit of paper, you have got example 2, which took me a whole side of A4 here to type up. So can you find that example, which may be split over 2 slides that you have, so you can stick that in your notes. Is it on 1 or 2 sort of bit? Yeah, okay. So either stick it in now or just work out what space you need to leave to stick that in now, and then we will go through this question.
I think I've got it with all the answers on it.
You will have done if you printed the whole thing off. Yes,
okay.
Correct. Okay. So there is a handout though, which is just a small print version of just the questions. If you want one, Ben, you can find one in. Ben?
Yeah.
If you want to, you can find it there. So let's just read it through a minute first of all.
There's just one.
The number of words typed in 1 minute by secretaries is normally distributed with a mean of 60 words a minute, a standard deviation of 15 words a minute.
It's 2.
A chair manufacturer claims that with their new super chair, the typist speed will improve. A random sample of 30 secretaries used the new chairs. Find the critical value for the number of words typed in 1 minute at the 5% significance level. I just want to stop there and say that's nothing new in this chapter. That's like old stuff. Can you just have a go at doing that before we move on? Okay, so I'll pause the video there. We'll look at that bit in a minute. But that is basically earlier chapter stuff. Nothing about errors. Just find the critical value. What would that speed have to rise to for us to come to the conclusion, yeah, the chairs have made a difference at the 5% level? And it's talking about improvement, so it's going to have how many tails? 1. 1 for improvement. We're only interested if it goes up.